Welcome. Mathematics 6th Standard Part 1 Playing with Numbers Chapter 3 Part 5 Test for divisibility of the numbers. Is number 38 divisible by 2, by 4 and by 5? How you find all this? By actually divide 38 by these numbers, we find that it is divisible by 2 but not by 4 and 5. Let's do this. 38 divided by 2. 2 ones are 1 is 3 minus 2 is 1. Take down this 8, 18, 2 nines are 18, 0, 0. When remainder is 0, then that number is divisible by 2. Let's try 38 divide by 4. 4, 4 was 16. 4 nines are 36. 8 minus 6 is 2. 2 is a remainder here, so it is not divisible by 4. 38 is not divisible by 4. Then 38 divide by 5 then. 5, 5 are 25, 5, 6 are 30, 5, 7 is a 55, 8 minus 5 is 3, 3 minus 3 is 0. If 3 is remainder, so it is not divisible by 5. So not divisible by 4, not divisible by 5. Let's see whether we can find the pattern that can tell us whether the number is divisible by 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Do you think such patterns can be easily seen? Yes, there is a pattern to find out whether the number is divisible by that number or not. Easy method without actually dividing the number. Divisibility by 10. Charu was looking at the multiples of 10. Multiples of 10 are 10, 20, 30, 40, 60, 50, 60. We found something common in these numbers, that is 0, end of these numbers. Can you tell what each of these numbers has 0 in one's place? He thought of some more problems with 0 at one's place. 100,000, 32, 100, 7,010. She also found that all such numbers are divisible by 10. She finds that if number has 0 in the ones place, then it is divisible by 10. Can you find out the divisibility rule for 100? Yes. If the number has in ones place and tens place are 0, then that number is divisible by 100. Two zeros at the end, that number is divisible by 100. Then divisibility by 5. Money found some interesting pattern in the numbers 5, 10, 15, 20, 25, 30, 35. Can you tell the pattern? Look at the unique place. All these numbers have either 0 or 5 in their ones place. We know that these numbers are divisible by 5. Money took up some more numbers that are divisible by 5, 105, 215, 6205, 3500. Again, these numbers have either 0 or 5 in their ones place. He tried to divide the numbers 23, 56. These are not divisible by 5. Will he be able to do that? Check it. He observed that the number which has either 0 or 5, its ones place is divisible by 5. Other numbers leave the remainder. This number 17,50,125 is it divisible by 5? Yes, it is divisible by 5. It is because it is ending with a 5 in the unit place. Divisibility by 2. Charo observes a few multiples of 2 to be 10, 12, 14, 16 are also numbers like 2,410, 43,056, 1,352, 2,972, 5,000, 5,974. She finds some pattern in one's place of these numbers. Can you tell that these numbers have only digits 0, 2, 4, 6, 8 in one's place? All the even numbers below 10 in the one's place. She divides these numbers 2 by 2 and gets the remainder 0. She also finds that numbers uh, 2,467, 4,829 are not divisible by 2. These are odd numbers. These numbers do not have 0 to 468 in their ones place. Looking at these observations concludes that the number is divisible by 2 if it has only the digits 0 to 468 in its ones place. Divisibility by 3. Are the numbers 21, 27, 36, 54, 219 divisible by 3? Yes, they are. Are the numbers 25, 37, 260 divisible by 3? No. How can you tell that? Can you see any pattern in the ones place? We cannot, because numbers with the same digit in the ones place can be divisible by 3 like 27, or may not be divisible by 3 like 1737. Let us try to add the digits of 21, 36, and 54, 219. We observe that 2 plus 1 is 3, 3 is divisible by 3. That's why 21 is divisible by 3. 3, 6, 3 plus 6 is 9. 9 is divisible by 3. 3 3s are 9. 5 plus 4 is 9. 9 is divisible by 3. 2 plus 1 is 2 plus 1 plus 9 is 12. 12 is divisible by 3. All these additions are divisible by 3. Add the digits in these numbers, get the number. That number is divisible by 3, then the whole number is divisible by 3. These are not divisible by 3. 2 plus 5 is 7. 7 is not divisible by 3. So this 25 is not divisible by 3. 3 plus 7 is 10. 37 is not divisible by 3 because 10 is not divisible by 3. 260. 2 plus 6 is 8. 8 is not divisible by 3. Therefore 260 is not divisible by 3. We say that if the sum of the digits is multiple of 3, then the number is divisible by 3. Is 7 2 to 1 divisible by 3? 7 plus 2 plus 2 plus 1. 7 plus 1 8, 8 plus 2 is 10, 10 plus 2 12 we get. 3 4s are 12, therefore 12 is divisible by 3. This number is divisible by 3 as. Then divide by 6. How you find this? Can you identify a number which is divisible by both 2 and 3? One such number is 18. Will 18 be divisible by 2 into 3? 6. Yes, it is. Find the more numbers like 18. Check if they are divisible by 6. Can you quickly think of the numbers which is divisible by 2 but not by 3? Now for the number given by 3 but not by 2. One such example is 27. 27 is divisible by 3 but not divisible by 2. Is 27 divisible by 6? No. Try find the numbers like 27. From these observations, we conclude that if number is divisible by 2 as well as 3 both, it is divisible by 6. It is a rule. Divisibility by 4. How you find this? Can we quickly give the 5 three-digit numbers divisible by 4? One such number is 212. Think of 4-digit numbers. One example is 1936. Observe the number formed by one sentence place of 212. That is 12. 12 is divisible by 4. It is 12 which is divisible by 4. And 36 is divisible by 4. Again, therefore, this whole number is divisible by 4. Try exercise with the other such numbers. For example, 4612. 12 is divisible by 4. Therefore, this number is divisible by 4. 16 is there. Last two digits. 16 is divisible by 4. 32. 32 is divisible by 4. Yes. 4 8s are 32. Is the number 286 divisible by 4? 86. Is it divisible by 4? 86. 4 2s are 8. 0. 6. No. 4 1s are 4. Remainder is 2. It is not divisible by 4. 86 is not divisible by 4. So we see that the number with 3 or more digits is divisible by 4 if the number formed by its last two digits, one sentence place, is divisible by 4. Check this rule by taking 10 more examples. Divisible for 1 and 2 digits by 4 has to be checked by the actual division. No other way. Divisibility by 8. Are the numbers 1000, 2000, 104, 2016 divisible by 8? How to find this? You can check that they are divisible by 8. Let us try to see pattern. Look at the digits at ones, tens, and hundreds place of these numbers. These are 000, 104, 416 respectively. These two are divisible by 8. Find some more numbers in which the numbers formed by digits at the units and tens and hundreds place is divisible by 8. For example, 216, 216, 216, 216. This is also 216 at the end. You will find the numbers themselves are divisible by 8. We find that number with 4 or more digits is divisible by 8 if the number formed by the last three digits is divisible by 8. For divisibility by 4, what we find last two digits. For 8, last three digits. The divisibility for the numbers with 1, 2, 3 digits by 8 has to be checked by actual division. Divisibility by 9. The multiples of 9 are 18, 27, 36, 45 and 54. These are other numbers like 4608, 52, 83 are also divisible by 9. Do you find any pattern with the digits of these numbers added? 18, 1 plus 8 is 9. 9 is divisible by 9. 2 plus 7 is 27. 2 plus 7 is 9. 9 is divisible by 9. 3 plus 6 is 9. 4 plus 5 is 9. 4 plus 6 plus 0 plus 8. 4 plus 6 plus 4, 10. 10 plus 8, 18. 18 is divisible by 9. 5 plus 2 plus 2 plus 8, 10. 10 plus 5, 15. 15 plus 3, 18. 18 is divisible by 9. All these sums are also divisible by 9. Is the number 758 divisible by 9? 7 plus 5 plus 8 is 20. It is also 20 is not divisible by 9. These observations lead us to say that if the sum of the digits of the number is divisible by 9, same as the divisibility test for 3 number, 9 is also same, then the number itself is divisible by 9. Then 11, the numbers 308, 1331, 61,809 are all divisible by 11. We form the table and see if the digits in these numbers lead to some pattern. 308, 8 plus 3 is 11. Sum of the digits at the odd places, it is 1, 2, 3, right? Odd places 8 plus 3 is 11. 1, 2, 3, 4. Odd places is 1, 3. 3 plus 1 is 4. And even places is 3 plus 1 is 4. 4 minus 4 is 0. 0 or 11 or multiple of 11, the answer should come. Then the whole number is divisible by 11. Again 1, 2, 3, 4, 5. Okay. Odd numbers are 9 plus 8 plus 6. 9 plus 8 plus 6 is 23. Then remaining 4 plus 2 is the even places. 0 plus 1 is 1. 23 minus 1 is 22. 22 is multiple of 11. We observe that in each cases difference is 0 or divisible by 11. All these numbers are also divisible by 11. For number 5081, the difference of the digits is even places is 8 plus 5 is 13. 13 minus 1 is 12. 12 is it divisible by 11? No. It is not divisible by 11. The number 5081 is also not divisible by 11. Thus, check the divisibility of the number by 11. The rule is to find the difference between the sum of the digits at the odd places from the right and then the sum of the digits at the even places from the right of the numbers. If the difference is either 0 or divisible by 11, then the number is divisible by 11. Please subscribe my channel and hit the bell icon and save the playlist. Thank you very much. Bye bye.